Welcome to qnawire.
All right, so here we have our equation. And in this equation, T is the input and Q is the output. So for the inverse, we would switch those and Q would be the input and T would be the output. And that means the meaning of the inverse is that we're going to find time as a function of charge, whereas what we have right now is charge as a function of time. Typically, when we find an inverse, we start by switching x and y and then solving for y. In this case, that would mean switching q and t and then solving for t. I do want to solve for t, but I'm going to be a little bit rebellious and I'm not going to switch q and t because I want t to stand for time and q to stand for charge, and if I switch them, their meaning is going to switch. So I'm just going to isolate t. So I'll start by dividing both sides by q naught. And then subtracting 1 from both sides. That should say minus. And then multiplying both sides by -1. That's going to give us 1 minus q over q naught equals e to the negative t over a. And then we'll take the natural log of both sides. So we have natural log of 1 minus q over q naught equals negative t over a. And then to get t by itself, we'll multiply both sides by the opposite of a. So we have t equals the opposite of a times the natural log of 1 minus q over q naught. Okay, so we'll count that as our inverse, time as a function of charge. Now we want to use that to figure out how long it takes to recharge the capacitor to 90% of capacity if A equals 2. So we want to find the time. And we know that Q is 90%. And we know that A is 2. Now, when we say that Q is 90%, we mean it's 90% of Q naught. So Q equals 0.9 times Q naught. Now our function was T equals negative A, so negative 2 times the natural log of 1 minus Q over Q naught, which would be 0.9 Q naught over Q naught. We can simplify that. That's T equals negative 2 times the natural log of 1 minus 0.9. Let's keep simplifying. T equals negative 2 times the natural log of 0.1. And let's go ahead and approximate that. We can put that in a calculator.